Okay, we're going to start on page 6 today. Before we talk about the practice problems over end behavior, which were your notes for homework last night, before we get to the end behavior stuff, I want to do a quick refresher on degree. So we talked about degree last week. You didn't have a notes video over it. We just talked about it in class for a couple minutes. So I want to talk about degree again really quickly, and then we'll get into how degree can tell us some stuff about end behavior, which again you saw in your notes last night. So remember, the degree of a polynomial when I have standard form is the largest exponent, okay, the biggest exponent, okay? So we're going to start by stating the degree, and then we'll, actually, let's start by circling what's in standard form. So remember, standard form is multiplied out and put in order, all like terms combined. So number one is in standard form. Number two is in what we would call factored form. We saw factored form in Algebra 1. This is where I've got those sort of parenthesis groups, and everything is what we would call a factor, something I would multiply together to get standard form. So number two is not standard form. Number three, again, I've got multiplication I would need to do here, so that's not standard form. Number four, there's no multiplication to do, but it's also not standard form because it's not in order. The term with the largest exponent is not first, so this is not standard form. Number five is in standard form. I only have one term here and it's just x. That's okay, that's standard form because it's in order. Number six, again, would be factored form because I've got distribution to do here. So 1 and 5 are in standard form. So this is where I'm going to look for that biggest exponent for my degree. So for number one, the degree would be 3. For number 5, the degree would be, if I don't see the exponent, that means that it's 1. So our degree for number 5 is 1. Number 4, if I were to rearrange this to put it into standard form, I could see that my degree is 2. And then for factored form, when I'm looking for my degree, remember that's where we add the exponent. And remember that for factored form, it has to be all things that are being multiplied together, okay? If I then tacked on like a plus 5x here at the end, this would not be factored form anymore, okay? I have to have all multiplication, okay? All sort of these parenthesis groups, these what we call factors being multiplied together. Then I would add the exponents. So my exponents would be 1 plus 2 plus 1. That looks like a 2. 1 plus 2 plus 1 gives me a degree of 4. For number 3, 2 plus 3 gives me a degree of 5. And for number 6, 1 plus 3 gives me a degree of 4. So we talked about degree again last week, and you saw it again in your notes from last time. The other thing we've got on page 6 are some just refresher of these operations that we talked about last week. So I want to go through a couple of these just as a reminder that we need to be careful about our problems. So we'll have a quiz at the end of this week over the things that we'll have talked about through today. So end behavior, adding, subtracting, multiplying, polynomials, and degree. One thing I want you to be very careful with are your operations with polynomials. So this is a subtraction problem. So make sure that we're subtracting, okay? What I see pretty frequently is that people see 2 groups of parentheses and just start distributing. So read your problem carefully. Since this is subtraction, I'm gonna go through and change my signs for the piece that I'm subtracting. And then remember, we combine like terms. So I would have 2m squared, and then 3m plus 5m would be 8m plus 8m. And then here's my only constant term, minus 5 there at the end. If I have a problem like number 9 where there's no sign in between this polynomial and the other polynomial, then I'm multiplying. If I have a sign in between, I'm subtracting or adding. If there's no sign in between, that's where we're multiplying. So here we would want to distribute. So this would be 3r cubed minus 2r squared plus r. And then do the same thing with the 7, distribute the 7, plus 21r squared minus 14r plus 7. And then my final step here is to combine like terms, and I want to put this into standard form. So my term with the biggest exponent, r cubed, goes first. It's my only r cubed term. Then I've got r squared, so negative 2r squared plus 21r squared would be 19r squared, so plus 19r squared. Then I've got r term, r minus 14r would be negative 13r, and then 7 is my only constant term, so plus 7. I would like you now to try number 8 and number 10. Try number 8 and number 10. Number 8, we're distributing. X squared times x squared would be x to the 4th. X squared times 2x would be 2x cubed. There are no like terms to combine here, and I've got standard form since my term with the largest exponent is first. So number 8 is done. For number 10, we're adding here. So that just means combining like terms. There's no multiplying. There's no distributing in this problem. It's an addition problem. So I'm going to look for like terms and combine them. My biggest exponent is 3. This is my only y cubed term. So I'm just going to put that one in front. And then I've got y squared and y squared. So this would be 3 plus negative 6. So it'd be negative 3y squared. Here's my only y term. So plus 4y. And then I've got constant terms of negative 5 and negative 3. When I combine those, I would get negative 8 or minus 8. Questions for me on our operations? Review from last week. Okay. What's the degree for number 8? What's the degree for number 8? 4. Yep. We have a degree of 4 here. How about number 7? What's our degree for number 7? 2. Good. Okay. So let's take a look at some of the end behavior work that you guys worked on for your notes yesterday. So when you went through your notes, you would have looked at the graph, you identified degrees for those problems, and then you talked about sort of the introduction to end behavior. So I want to talk about some sort of general terms we're going to get, and then we're going to do our practice problems, okay? So I want to talk about the bottom of page 8. You guys saw the graphs in your notes, so I don't want to spend our time on that for today, but I do want to talk about these sort of generalizations that we have. So the big idea is that we can have even degrees or odd degrees. So I'm on the bottom of page 8 right now. Either the degree for my function is even or odd. Okay. Remember, even numbers would be like 2, 4, 6, 8. Odd would be 1, 3, 5, 9. Okay. So either my degree is even or odd. And then the other thing I want to look at is my lead coefficient. So I could have a positive lead coefficient or a negative lead coefficient. That just means the number in front is positive or the number in front is negative. Okay. So I've got two options for degree, even or odd. I've got two options for lead coefficient, positive or negative. Okay. So those two pieces of information tell me about the general shape of my graph. If I have an even degree, my ends are going to go in the same direction. Always. If you have an even degree, your ends are going to go in the same direction. If your lead coefficient is positive, that means both ends go up. Even degree and a positive lead coefficient means both of your ends will go up. Now you may have nothing crazy that happens in between those two ends, or you may have all sorts of bumps and wiggles and dips and weird stuff that happens in between those two ends. But the big idea is that the ends both go up. Remember, for end behavior, we're just focused on what the ends of that graph do. If I have an even degree with a negative lead coefficient, then both of my ends go down. So we saw functions like this and like this in Algebra 1. Okay, towards the end of the year, those were our parabolas. If I had a positive lead coefficient, it opened up. If I had a negative lead coefficient, it opened down. What we're going to see with our broader category of polynomials is that I may have more crazy stuff that happens in the middle, but my ends will do the same thing. For an odd degree polynomial, my ends go in the opposite direction. Odd, opposite. Okay. For an odd degree polynomial, your ends go in the opposite direction. A linear function is an example of an odd degree polynomial, right? A linear function looks like a line when we graph it. If I have a positive lead coefficient, that would be a line with a positive slope. So it would look like this. You guys have been graphing lines for years, and so you know that your ends are going to go in different directions. Now, we'll also see polynomials where I get more complicated things that happen in the middle, but the big idea is that your ends point in opposite directions. Your arrows are going to point in opposite directions. One arrow will point down, one arrow will point up. If your lead coefficient is positive, it's going to be a general trend up from left to right. So general trend up from left to right. If I have a negative lead coefficient, we'll flip this. So this would be like a line with a negative slope. My ends are still going in opposite directions. My arrows point in opposite directions. And if I'm not talking about a line, I'm talking about some other kind of function. I may have goofy stuff that happens in the middle, but the ends are still pointing in opposite directions. Those arrows point in opposite directions. So when we talk about end behavior, I can tell you the end behavior of any polynomial with just those two pieces of information. What's the degree? Or really just is the degree even or odd? I don't even have to know the number, just if it's even or odd. And then what's the lead coefficient? Is it positive or negative? Okay, with just those two pieces of information, I can give you the end behavior. What we're filling in for end behavior when we talk about polynomials is always going to be either positive infinity or negative infinity. Okay, for polynomials, those are our only options. We'll talk about other functions later this year where we can have ends do different things. They won't just point up or down. But for polynomials, just positive infinity or negative infinity, okay? So we have this whole big kind of messy looking setup here. This part is always going to look the same. So as x approaches negative infinity, this means that we're talking about the left side of the graph. right? If I look at a coordinate plane, this is the left side of the graph when x is like negative numbers, right? Like here's maybe -5. And then when x approaches positive infinity, that means when x is positive numbers. So that's the right side of the graph. This part's always going to be the same. You're just going to fill in what y does, okay? That's the only thing that you have to worry about. So the only question I'm really asking you here is, does the arrow at the end point up or does the arrow at the end point down? If it points up, you're going to write positive infinity. If it points down, you're going to write negative infinity, okay? That's what you're telling me with end behavior. Which way does the arrow point? So let's take a look at some practice problems on page 9. That's what we're going to fill in here. We're going to use degree and lead coefficient to say which way the arrow points on page 9. So for number 1, my degree is 3. And my lead coefficient, the coefficient at the very front, is positive. Odd degree, they go opposite. Odd goes opposite. Since it's positive, it will have a generally positive slope, up from left to right. So now as I'm asking you about the end behavior, when x is some negative number, so as I'm like formally reading this with mathematical training, this says as x approaches negative infinity, so as x gets closer and closer to negative infinity, I pick smaller and smaller x values, x is negative, when x is negative, right? This side of the graph, which way is the arrow pointing? Down, right? If it's down, I write negative infinity. This says as x approaches positive infinity, so when x gets to be bigger and bigger numbers. So when x is a positive number, this side of the graph, where's our arrow point? Up. So if the arrow points up, we write infinity. So I look at these two pieces of information. I like to sketch a little picture here, and then I fill in my end behavior. Okay, either negative infinity or positive infinity. So we'll do the same thing with number 2. I've got standard form here again. My degree is 5. And this time my lead coefficient is negative. Okay, odd ends go opposite. Since it's negative, that would be like a line with negative slope. On the left side, when x would be a negative number, so that'd be over here somewhere, my arrow is pointing up. So this would be positive infinity. As x approaches infinity, so on the right side, when x is positive, the arrow on this side of the graph is pointing down. So we would say y approaches negative infinity, because my y values get smaller as I continue to the right. Because we have standard form, our degree is the biggest exponent. Let's take a look at one that's not in standard form. So let's hop down to number 8. This is in factored form, right? I have distribution I would need to do here. So my degree here, I would have to add the exponents. So 3 and 1 means my degree here would be 4. Right? I add when it's in that factored form. So my degree is 4, and my lead coefficient would be positive. Right? There's no negative sign there, so my lead coefficient is positive. When we have even degree, our ends are going to go in the same direction. since our lead coefficient is positive, they're both going to go up. So our info in the same direction. Since our lead coefficient is positive, they both go up. So on the left side of the graph, this arrow points up. So I'm going to fill in infinity. On the right side of the graph, my arrow also points up. So again, I'm going to fill in infinity or positive infinity. I would like you now to try number 3, number 4, and number 6. 3, 4, and 6. What's our degree for number 3? 6. It's in standard form, so I just look for the biggest exponent. And then our lead coefficient, is that positive or negative? Positive. I just look at the number in front, right? If I see a negative sign, it's negative. If I don't see a negative sign, it's positive. So I have an even degree and a positive lead coefficient. That's the same setup we had for number 8. So I know the general shape of my graph will be something like this. So what would I fill in here? On the left side of the graph, where's y going? Up. So I would write, if I'm going up, I write positive infinity. Sorry, I just couldn't hear you. Okay, positive infinity. On the right side of the graph, I'm going up again. So I'm going to write another positive infinity. For number 4, what's our degree? 3. And our lead coefficient is negative. Yeah, negative on this one. So this is the same setup we had as number 2. Odd degree with a negative lead coefficient means I've got something that generally looks like this. So on the left side of the graph, my arrow's pointing up. So I would write positive infinity. On the right side of the graph, my arrow's pointing down. So I would write negative infinity. Not too terrible. Okay. For end behavior for polynomials, you only have 2 options, infinity or negative infinity. Okay. And it's based on, again, whether that arrow points up or down. Number 6, what's my degree here? Yeah, this one's in factored form, so you have to add up the exponents. My degree here is 3, and our lead coefficient is positive. So it would look generally like this. So it's opposite of what we just looked at with number 4. So on the left, since that arrow is pointing down, y approaches negative infinity. On the right, since my arrow is pointing up, y approaches positive infinity. Let's look at 5 and 7 as well. Some more practice with degree for these factored forms. What's my degree for number 5? 3, yeah, 1, 2, 3. My lead coefficient is negative. So I've got this general shape. Where's y going to go on the left side of the graph? To positive infinity. Where's y going to go on the right side of the graph? Negative infinity. Good. What's our degree for number 7? 4. 1, 2, 3, 4. And our least coefficient is? Sorry. Least coefficient? Negative. So this is going to be an upside down sort of parabola looking thing. So on the left side of the graph, y is going to go towards negative infinity, and then the other one also negative infinity. Good. Let's hop down to actually, let's stop and look at number 9. For number 9, we've got end behavior. I want to know what kind of function would have this end behavior. So I've got the left side of my graph going up, the right side of my graph also going up. What kind of degree would I need to have for the ends to both go up? Positively coefficient. And then what about the degree if the ends go in the same direction? Has to be even. For number 10, the left side's going up, the right side's going down. So what needs to be true about this function? Has to be what? I'm sorry. It has to be an odd degree with a negative lead coefficient. There are a lot of different functions I could write to fit either of those descriptions, but the key features that I need to have are positive lead coefficient and even degree for number 9, negative lead coefficient and odd degree for number 10. Good. And then number 11, which function has the same end behavior as the polynomial that we have graphed here? I don't have a function for this, but I can tell those two pieces of information based on the ends. Both my ends are pointing down. So what do I know has to be true about the function? Even degree, and a negative lead coefficient. Good. So of the functions I have down here, which of them has an even degree and a negative lead coefficient? See, yeah, I can throw out A and B because they don't have negative lead coefficients. And then if I look at degree, D has a degree of 3, C would have a degree of 4. So since C is also a negative lead coefficient and an even degree, it's going to have the same end behavior. The middle part of the graph may look different. It might have different X and Y intercepts, different minimums and maximums, but the ends are both going to go down, just like they do for our graph here. Questions for me? Okay. With our time remaining in class, you have an assignment on end behavior on Delta Math. You can use your own device or a Chromebook from the cart if you would prefer. So I want you guys to work on your assignment on Delta Math.